In meeting ID, there is a difference in meeting ID. Yeah. Assalamu alaikum all. We'll be waiting another 4 minutes to start the class. Please bear with us. Uh, shall we start or we can wait for another 5 minutes, Sarfraz?
I think let's wait for 5 minutes.
Thank you. Uh, your voice is getting echoed because you're
Should we
logging
start
in.
or we can wait for another 5 minutes, Sarfraz?
Yes, Mr. Sarfraz, you can start. Think people are waiting. There are more peoples in YouTube rather in Zoom, actually. When I see the statistics,
Yes, Mr. Sarfraz, you can start. Think. People in YouTube rather in Zoom, actually. When I see the statistics, yes, Mr. Sarfraz, you can start. Think.
Hello? 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 Can you hear me? Hello?
Yes, yes, we can hear you.
Okay, wait. Can you wait for 2 minutes? Actually, I'm not able to share my screen. The PDF which I have made, I'm not able to share actually. Hello? Sir, can you make me host? I'm not able to share my screen actually. Tanvir sir, hello?
you are a co-host.
Sir, can you make me host? I'm not able to share
Yeah, okay.
screen.
I'll do that. I've done the host.
Okay, okay.
Right now, can you now, Mr. Sarfaraz?
No, sir.
See, you are the host now.
Yes, sir, I am on the host, but still I am not able to share.
No, before it was happening. Now, when you tested, it was running. When you tried sharing.
Can you see my PDF?
No, we
No,
cannot.
that only actually that my content is there. I have to share that content. I don't know why it's not being shared.
If you want to try with your other ID, personal ID,
Let me try with that ID.
yes, please.
Personal ID.
Here all there is some technical issues we are solving out. I will start in few minutes.
Yes, Sarfaraz sir, now we can see your screen.
Okay. Okay, so we are going to study. Can you hear me, everyone?
Yes.
Okay. So we are going to study about the climatology. I think for the last lecture, you have studied about the climatology as well. So, but only few topics were you able to cover. But from now onwards, we are going to cover the whole topic of climatology. Okay, so what we are going to study for the first few minutes will be about simple topics like what is climate weather, what is atmosphere, what is composition of atmosphere, what is gases in atmosphere and layers of atmosphere. These 4 5 topics we will be studied. In simple terms, if we will compare weather and climate, then weather is the right now what is kind of outside climate is there. Actually, it should not be called outside what a local weather is there. It will be called as a weather. It is kind of right now whatever the wind speed, temperature, or moisture, pressure is there outside in the environment, it is called as the weather. Whereas when we talk about climate, climate is the average daily weather for an extended period. So for example, weather, even during winter, a weather can be sunny weather, but we will, as per climate, we will say it is a winter. Okay, so weather is a very local and local phenomena, where the main difference between weather and climate is about the time period. Okay, weather is for temporary period, climate is for the average long period. Okay, so now coming to how when we say about climate, so what are the part of the atmosphere that will become a climate? That's very important. So when we say about climate, so the first few things which we should know is what is our atmosphere, and in this atmosphere, what are the different types of gas, what are the temperature difference, what is the moisture, what is pressure, these kind of things we should be knowing. So the climate, if you talk about first atmosphere, then atmosphere is nothing. Okay, we cannot see atmosphere, we can feel atmosphere. So in simple terms, atmosphere is a mixture of different gases which envelops around the earth. Okay, so when we talk about and it envelops around the earth, means it is not like there is a difference between atmosphere and space. Okay, when we will see the different parts of atmosphere, for example, if just I will take you, okay, see this, see the atmosphere, the part of atmosphere are troposphere, stratosphere, mesosphere, thermosphere, exosphere. All these are part of atmosphere. After this exosphere starts a space. Okay, so an atmosphere in simple terms, it is nothing but as per the definition, it is a mixture of different gases and it envelops around the earth. Okay, so earth is there, and around the earth atmosphere is there. So, and it is made up of 99% of the things are confined to 32 kilometer of the earth surface. Okay, so for example, what the atmosphere could be around, like if you talk about the atmosphere, it is around 3000 kilometer above the sky, and from ground till the above sky it is 3000 kilometer. But most of the maximum mass of the atmosphere are restricted to 32 kilometer, means stratosphere and little bit of mesosphere. So 99% of our total mass of atmosphere, means maximum things which we are talking about atmosphere are within 32 kilometer from the earth surface. Okay, so stratosphere or max to max mesosphere. And there are different types of gases in the atmosphere. We say the atmosphere is nothing but a mixture of gases. So what are the different type of gases? So many different types of gases are there: nitrogen, oxygen, argon, carbon dioxide. But we have to remember only, I would say, instead of remembering everything, we just have to remember only 4-5 things. Okay, first is nitrogen. Nitrogen is around 78% and oxygen is around 20%. Then after nitrogen, oxygen, I would say argon, carbon dioxide, and hydrogen. Only these three, apart from nitrogen, oxygen, are important. See, nitrogen, oxygen are important for human being to survive. Okay, because see, nitrogen is very important as a building block of human cell. So nitrogen in that context, it is very important. So, and it is part of atmosphere. And oxygen also, we inhale atmosphere oxygen, and we absorb, we inhale oxygen, and we exhale carbon dioxide. So these gases are important. But when we see about the composition, maximum composition around, if 98% of gases are nitrogen and oxygen. Only these two gases are 98% of gases in the atmosphere. Okay, so all the gases which is available in the atmosphere, the maximum dominance is of nitrogen and then oxygen. The third one is argon, and fourth one is carbon dioxide, and the least one is hydrogen. These 5 gases are important. But the carbon dioxide, which is not good for climate, or which increases our earth's temperature, is increasing day by day because of pollution and number of things. So because of increasing carbon dioxide, there is a concept of global warming. And because of global warming, what is happening? because of global warming, there is a climate change issue. So what we right now, if we talk about carbon dioxide, the n number of countries have come together under one organization name as United Nations. So and these organization are trying, and n number of countries coming under this organization is trying that they should reduce the carbon dioxide from the atmosphere, which is growing. There is naturally available of carbon dioxide, and that is important. The natural little bit naturally available of carbon dioxide is important, and why it is important we will understand right now. So the importance of carbon dioxide lies, okay, so when our solar radiation is coming, okay, solar radiation comes from sun, okay, so the carbon dioxide is transparent to incoming solar radiation, okay, it is not blocking the incoming solar radiation, but it is opaque to outgoing terrestrial radiation. Opaque means it blocks, okay, it does not allow the whole solar radiation to go out. Okay, when solar radiation comes in, when solar radiation come inside the earth, then what they are going to do is, first the solar radiation will heat up the land, and the land will start to produce some of the radiation, heat radiation, that will be called as the terrestrial radiation. And these terrestrial radiation would not be able to leave the earth because carbon dioxide is going to capture that. And because of this capture of terrestrial radiation, okay, the temperature on the earth is habitable. This is the reason, and this natural phenomena is important for our adequate amount of heat or temperature should be there for a human being to survive. Otherwise, if extreme temperature is there, human being will not be able to survive. So the adequate temperature which is required for the earth to be heated is very much provided with the help of carbon dioxide. But because of the increase in the carbon dioxide, the temperature which is unbearable to human being is also increasing, and these increasing temperature is called as global warming. So global warming is not only affecting human beings, global warming is also affecting all the natural and other climatic factors as well. So if you will see nowadays, heavy rainfall is there, or cyclone, okay, super cyclone, these kind of things are there because of the global warming which is affecting the climate change. Okay, so this is just, we don't have to go into that deep, just to make you understand the importance of carbon dioxide. Most of the people will think, okay, carbon dioxide is not good, but it is good to some extent. Beyond the limits, anything beyond the limit becomes a pollution or harmful. Now coming to ozone layer. So our atmosphere also has an ozone layer. This ozone layer is found between 10 to 15 kilometers above the Earth's surface, and mainly it is in the stratosphere. This diagram which I showed you. So when first there is troposphere, then there is stratosphere, then there is mesosphere, then there is thermosphere and exosphere. So this stratosphere, the second level, okay, is known for ozone layer. What is the importance of ozone layer? Can anyone say what is the importance of ozone layer? Any students would like to say anything about ozone layer?
Protecting life on the planet.
What? Please be little louder if
Protecting
possible.
from UV radiations.
Okay, right. Okay. So how it protects? It absorbs the harmful UV radiation. It does not absorbs all the UV radiation, but it absorbs the harmful UV radiation. Okay, the harmful UV radiation is ultraviolet, or in simple terms, when the solar radiation is coming, there are different type of radiations. And one type is UV radiation. And in this UV radiation, some of the UV radiation are very harmful, which can affect human beings. It can cause skin cancer and multiple different effects it has. So the ozone help us protects us from UV radiation. Okay, and there is all like, it's not important here, just to make you aware, there is also ground level ozone. Okay, ground level ozone is not good for health. It is a kind of pollution. Okay, it is a pollutant which is not good for health. So ground level ozone is basically it comes because of the automobile and petrol. Okay, the automobile and petrol, when automobile uses petrol, so it releases some of the volatile organic compounds, which later on converts into ground level ozone, which is harmful for human being. So just to make you aware of, there is a difference between ozone layer, the ozone which is in the upper level and the ground level. So ground level ozone is not good for health, but at the same time, upper level ozone protect us from the UV radiation. Then the other components in the atmosphere is water vapor. Okay, so water vapor is normally available. Okay, so the water from the sea, from the soil, from trees. Okay, trees through transpiration, human through sweating. There are multiple ways through which the water vapor adds into the atmosphere. Okay, but it decreases with altitude. As altitude means height. Okay, in simple terms, altitude means height. As we go up and up and up, the water vapor will reduce. Okay, so and most of the water vapor will be till troposphere only. Okay, sometimes the cloud will form in stratosphere, but most of the time the water vapor will be in the troposphere only, and it decreases with altitude. Okay, the more near the ground you are, so at surface level water vapor in the atmosphere will be high, but as you go up, the water vapor will come down. For example, if you see in coastal areas or the ground level, okay, the rivers are there, multiple water sources are there. Because of that, continuous water supply will be there for the atmosphere. But as we go above the hill, there is not much water source available, so there will be less amount of water vapor in the atmosphere in the hilly areas. So this is also, we can say, just to make you compare that, okay, with the increase in the altitude or height, there is a decrease in the water vapor. Okay, so and also one more thing is key, equator will have more water vapor, and poles side there will be have less water vapor. This we will understand when we will study heat distribution because the maximum heat will be near equator. So the water will easily evaporate and become vapor. So it will be more, therefore there will be more water vapor in the equator, but towards the pole it will start decreasing. Similarly, like to some extent, the way carbon dioxide was responsible for heating the earth, similarly water vapor is also responsible for the heating the earth. Okay, it also absorbs part of the insulation, and some of the it, like we can say that, okay, sometimes it also help in cooling down also. When it absorbs the heat from the atmosphere, somehow it reduces the temperature. Okay, and the here it also contributes to stability and instability in the air. What is the meaning of stability and instability? Here, whenever there is a rain, it is rain or any like rain like climate, then it is called as instability. When there is cool calm weather, no rain, then it is called stability. I hope you will remember this. Whenever you heard about the word instability and stability in context of geography or atmosphere, you should remember that. Okay, when we are talking about stability, they are saying on a cool and calm weather. When we are talking about instability, then there is a weather which is pointing towards there will be a rainfall. Okay, now see, dust particles also becomes part of your atmosphere. Okay, sometimes we can see the dust particles, and sometimes the dust particle will be so small that we will not be able to see. Okay, when we say about dust particle, it is not necessary it is some related to dust only. Sometimes even the small particles of anything, okay, will be considered as a dust particle, because uh, not necessary that it is some pollution or something like that, but because they are so small that we cannot see it, we will consider it as a dust particle. So the most important aspect of dust particle, it is that it act as a, see, this is a technical term, hygroscopic nuclei. Okay, see, what is the meaning of hygroscopic nuclei? Just it is just a one point where the water vapor will condense. Okay, means now water vapor means it is a gas form. Condense means it will convert into a liquid form. Okay, after condensation, it will convert into a liquid form. So water vapor condenses to produce clouds. So once the cloud is formed, then there will be a rainfall. So dust particles plays an important role for cloud to form and rainfall to happen. Okay, if there would not be any hygroscopic nuclei, then water vapor would have been remain into vapor only. It would not have been condensed or converted into clouds. So hygroscopic nuclei is a must for a cloud to form. Okay, so one example I would like to give you, like few years ago, there was a volcanic eruption in the Southeast Asia. And when the volcanic eruption is there, volcanic eruption releases a lot of dust particles. And these dust particles act as a hygroscopic nuclei where all the water condensation happened, and there was a huge amount of rainfall also in that area. Not only in that area, around that area, a lot of around, because the when the dust particles came out of that volcano, a lot of it spread to a huge area. And when it spread to a huge area, then there was a heavy rainfall in many areas. Okay, so the layers we already saw that there are 5 different types of layer, but now we will go a little bit depth. Okay, so I am hiding this. Any students would like to, without saying, would like to say all the 5 layers of atmosphere? Hello. Hello, any student would like to? Okay, I think no one would like to say. Okay, let's continue then. Okay, then there are 5 different layers of atmosphere. The layer which is very close to ground is troposphere. Okay, it is around from its height is on an average from 12 to 18 kilometers. Then there is a stratosphere. Okay, then there is mesosphere, then there is thermosphere, then there is exosphere. We will see one by one. What does it mean? Okay, so the troposphere is the lowermost layer of atmosphere, and average height is 13 kilometer. So the average height is saying on like 8 kilometer near the poles and 18 kilometers at the equator. Then why it is 8 kilometer near the poles and why it is 18 kilometer at the equator? The reason is you will understand from solar radiation. The structure of the earth is in such a way that when the solar radiation is at the equator, it is directly coming to the equator. Okay, and when it is coming directly at the equator, the heat will be more, and because of heat, the evaporation will be high. Because the evaporation is high, so the troposphere level will be high, because a lot of water vapor and other type of gases will be there in the equator at till 18 kilometer, around 18 kilometer. Okay, this is the reason why there will be height. The most important reason is the solar radiation or the heat. Okay, similarly, when we talk about the polar region, when we see the polar region, in this region, because of the curvature of the earth, okay, because the earth is circle, and because of the curve of the earth, there is, when the solar radiation falls on it, the solar radiation does not directly goes to the pole region. It gets distributed in that curvature, and then it reaches to the surface of the earth. So at the pole region, the less amount of heat or less amount of solar radiation is coming at the pole region. Because of that, only very less amount, because less heat, so less water evaporation will happen, less other gases will be formed, and this is the reason why there is only 8 kilometer height near the poles of troposphere. So this means the troposphere does not have a common height everywhere. It height changes from equator towards the poles. Okay, so we can say, in simple terms, we can say thickness is greatest at the equator and when comparison to poles. Okay, and most of the climatic and weather phenomena, whatever like rainfall, cyclone, whatever you are seeing related to climate and weather, it is happening within this layer. Okay, summer, winter, everything, whatever you can see, it is happening between this weather region. And the most important aspect of climate and weather is the rain. So the most of the rainfall, clouds, and everything happen in this layer. Okay, and we can say as we go up height, as we go up in the height, there the temperature will start decreasing. Okay, but see, it is not like this. The temperature will decrease from troposphere till the exosphere. In between, okay, in between the temperature will change, and we will see why the temperature is changing. What is the reason why again it started increasing? Okay, so in the troposphere, normally if we will go up, and we can see when we are at the surface level, ground level, near coastal area or near plain area, that time the temperature, is very high. But when we go to any hilly region or the mountain areas, okay, hill stations, that time that we will understand, okay, the temperature is less there. So this is the reason why people mostly in the summer prefers to go to hill stations. Now troposphere, see, just above troposphere, before the start of the stratosphere, there is a one area called as tropopause. Okay, this area is tropopause. It is called as the zone of separating stratosphere and troposphere. Okay, this layer has everything in common. Like the here troposphere, when we saw about troposphere, the temperature was decreasing, but here the temperature will remain common. Okay, in that area the temperature will remain common, it will not change, but it will change from equator towards the pole. Not in the height, it will not change in altitude, but it will change from equator towards pole. See, here the way the equator was having the high temperature, similarly the equator at tropopause will also have a very low temperature, -80 till it will reach till -80 degrees Celsius, whereas poles it will reach till -45 degrees Celsius only. Okay, so but tropopause is not that important. The important is stratosphere, troposphere, stratosphere. These kind of layers are important. Now again coming back to stratosphere. Stratosphere here, the way it was in troposphere, the height was still 18 kilometers. On an average, it was 13 kilometer, but on equator it was around 18 kilometers. But stratosphere it is up to 50 kilometer. So we can say, like for example, we can just say, okay, see now up to 50 kilometer means it will vary. It is also not like a straight line. It will vary. But just for our understanding, just for our better use of information, the science has used, or the person involved in the atmosphere research, they have used this, like only up to 50 kilometer will be stratosphere, but it can go up to more than 50 kilometer also, it can be less than 50 kilometer also. But for our understanding and for our exam purpose, we will only focus on this up to 50 kilometer. Okay, then it contains ozone layer. Now this is very important. The stratosphere contains ozone layer. You should remember this information, and this is a very important information. As we already discussed, ozone. Okay, ozone is an important gas in the atmosphere. Okay, and it absorbs UV. Okay, because it is absorbing UV rays, in this layer the temperature increases because they are absorbing solar radiation. The reason, because they are absorbing solar radiation, the temperature will start increasing in this region. As see, we saw that in troposphere, as we were moving up, the temperature was decreasing, but in stratosphere, because ozone is there, and ozone is absorbing UV rays or solar radiation, because of that, as we will go up more up, the temperature will increase. I hope you understood this, because this is important. Someone would say, okay, yes, something. Hello?
Yes, sir.
Okay. Did you understood stratosphere, why the temperature will increase? Normally we have an idea, okay, like when we were kid or when we were studying not into depth, then we will think, okay, as I will go up, the temperature will only decrease. But after troposphere, when we will enter into stratosphere, the temperature will again start to increase. Okay, remember this information. This is important. And why it will again start to increase? Because there is a ozone layer, and because of ozone layer absorbs heat or solar radiation or UV rays. Because of that, the temperature in the stratosphere increases. I hope you understood this. You have to remember this information. This is important information. Okay, then similarly, the way tropopause was there, similarly stratopause is there. It is between stratosphere and mesosphere. That's just you should know. Okay, tropopause, stratopause, mesopause. Okay, nothing much important. Okay, only thing is that okay, that layer will have no changes will be there. Okay, stratosphere. See, in the stratosphere, the temperature was increasing with altitude, but when we will go to stratopause, the temperature will remain uniform throughout the layer. It will not increase or decrease with increase in altitude. Now coming to mesosphere. Mesosphere is a layer, atmospheric layer, where it extend up to 82 kilometer. Up to 80 kilometer, okay, and here temperature will again start to decrease with height. Okay, here again temperature will decrease with height. The normal phenomena will be there because they do not have ozone layer to increase their height, to increase their temperature. Okay, so in this mesosphere, it will act normally. Temperature will decrease with height. Okay, don't take tension. I will show you one diagram. In that diagram, you will understand how to remember. Okay, how to remember when temperature decreasing, when increasing. Otherwise, it can become a confusing thing. Okay, so now mesosphere is there. See, the mesosphere is that layer of atmosphere where whenever there is a meteor shower. Okay, I hope you know what is meteor, a rock from a space coming inside the earth. Okay, when a rock is there, because earth and other planets are mostly made up of rocks, and and some of the rocks are not able to consolidate into a planet, they are roaming freely in the space. When that free roaming rock comes inside the earth, and it's inside the earth, as soon as they entered the atmosphere of the earth, it will start to fall down because of the gravity attracts everything towards the ground. So because of that, meteor will start to fall down in the atmosphere in a very high speed. So at one point of time, when it will enter into mesosphere, the meteor will start to burn. Okay, and sometimes we have seen that, okay, this is a normally in Hindi we say toota hua tara. People had that, okay, the star is something is happening to a star, and people will say, okay, let's make a wish, something like that. But it is not a star, it is a meteor shower is there in the sky. A meteor has entered into a mesosphere and it has started to burn, it has started to catch fire. Okay, so in this mesosphere, that fire starts to starts to catch that fire. Okay, so why it is happening? Because a lot of different types of gas, dust particles, other things are there. Okay, though at a very low quantity, but it is there. When it is colliding with the high speed moving meteor, then there will be a fire. Similarly, there is a mesopause between mesosphere and thermosphere. It is not that important. The important things are mesosphere, stratosphere. Okay. Then the very next above mesopause is thermosphere. Okay, thermosphere is also very important. Okay, it is also known as ionosphere. Okay, why it is known as ionosphere? I will say. Okay, the first, its height is between 80 to 400 kilometer. Okay, why it is called as ionosphere? Because it contains electrically charged particles. Okay, thermosphere contains electrically charged particles. Okay, so normally see radio waves are used for like radio waves in communication. Okay, for example, uh, if you want to have a call or something like that, then how that radio waves transmit. Okay, so the radio waves goes up in the sky, and when it reach the thermosphere or ionosphere, because of the electrically charged particles, they will be reflect back. So this is how the way radio waves are transmitted from the earth, and it is reflected back to the earth by this layer. So it will reach to a person or it will reach to another device. Okay, so the radio the ionosphere, the phenomena of ionosphere, the phenomena of thermosphere is used in the communication technologies, especially with respect to radio waves. So the radio waves will go up automatically, then because of the ionosphere or because of the electrically charged particles, the radio waves will be reflected back towards the earth. Okay, see, because it contains electrically charged particles, here also the temperature increases with height. Okay, and a very beautiful phenomena happens in this thermosphere. It is called as aurora. Okay, this is called as aurora. What is the meaning of aurora? Anyone knows what is the meaning of aurora? Any student? Have you seen some of the photos of very beautiful sky colors, green
Yes,
color,
sir. I have
blue
heard
color?
about Aurora Borealis, but do you
Ah,
know the main meaning of that?
okay. Let me explain. So the sky, when we see the different types of colors in the sky, very dark green or blue color, red color, huh? Not the normal evening like sunsets. Huh? I'm talking about the sky color, very different colors. Okay, this is mostly happens in the northern pole or southern pole, means above temperate and all. Okay, sometimes it can happen into nearby tropical region, but mostly uh, whenever it is happening in a nearby tropical or equator region, it will be a rare phenomena. But mostly it happens near the equator in temperate region. For example, Canada, Russia, in these kind of areas, these colorful skies, beautiful skies will be seen. What is happening? The sun. Okay, the sun releases a lot of different types of energy particles. Okay, one energy particles comes in the form of solar radiation, another comes in the form of a solar particles. Okay, so when these solar particles is coming, and it is very harmful for our communication technology and for a lot of normally it can be harmful for human beings also as well. But because our earth already has an electromagnetic coverage, or this atmosphere also to some extent help us, and because thermosphere has an ionosphere, and when these solar particles, okay, when these solar particles are trying to enter earth, so these the first of all they would not be able to enter the earth. Okay, because of the electromagnetic we have because of the electromagnetic phenomena which protects the earth from the other charged particles. So but there are some small gaps in the northern hemisphere, near the north pole and south pole, and through that region a very little amount of solar charged particles or solar particles will come inside. And when it comes inside, when it reaches thermosphere, there is ionosphere, there is already electrically charged particles. And when these electrically charged particles collide with each other, or so at that time when they collide with each other, so that time different types of colors will be seen in the sky. This is called as aurora. Okay, there are two types of aurora. Okay, for north aurora borealis, for south aurora australis. Okay, southern hemisphere there is Australia. So this is how we should aurora australis is in the southern hemisphere. Okay, then there is exosphere. Exosphere is just above thermosphere. We do not know where its boundary ends. Okay, and actually, it is very difficult to analyze exosphere because it is almost sharing border with the space. Okay, so we don't know much about the exosphere. Okay, we know it is also part of atmosphere, and it is the the last part of atmosphere. Okay, so this diagram, I was talking about this diagram. If you can remember this diagram, you will remember the temperature difference. See the lower level, okay, on the x-axis temperature is written. Okay, so it starts from minus 100 degrees Celsius, minus 80, minus 60, minus 40, minus 20, 0 degree, and 20 degrees Celsius. And the y-axis, okay, the vertical line, it is given altitude in kilometers. So it starts from 0, it's here till thermosphere, it is showing 400. But if you will see exosphere, it can go up to 2000, something like that. Okay, just give me a break, 1 minute. Okay, so see, in troposphere, just for understanding we have taken, okay, just focus on the troposphere layer. Okay, in troposphere the temperature at surface level is around Around 18 degrees Celsius or 19 degrees Celsius or 20 degrees Celsius, depends on different, but on an average, 18 degrees Celsius they have taken. See, as the height is increasing, the temperature is decreasing. See, it reached till minus 60 degrees Celsius. Okay, on an average, it reached minus 60 degrees Celsius. Then there comes a tropopause. See, when it comes a tropopause, then there is a uniform temperature. There is no change in temperature. Okay, then we moved in the stratosphere. See, in this stratosphere, because of ozone layer, again the temperature is increasing. Okay, then mesosphere, again the normal phenomena, temperature is started decreasing. Then thermosphere, because of the electrically charged particles, again the temperature is increasing. So it's a zigzag. Even if you exactly don't remember in real examination, you can just make a diagram in a very quick manner. Okay, zigzag. Okay, one time this side, then again one time you have to move towards left, then again right side, then left side, then right side. Okay, if you will remember this zigzag, even whatever I have taught you, okay, decrease your temperature, increase your temperature, because it can be sometimes confusing. Okay, but just you have to remember the order of the atmosphere. Okay, the layer of the atmosphere. First there is troposphere, then second the layer is stratosphere, the third layer is mesosphere, the fourth layer is thermosphere, then the fifth layer is exosphere. If you remember all these things, if you remember this diagram, most of the phenomena which I have teached or talked with you right now, you will remember this. Okay, if I would be at your place, I would take this diagram and I would add more things, like in this stratosphere I will write, okay, ozone is here. Okay, then thermosphere, okay, ionosphere is here, electrically charged particle is here, because of this aurora happens. Troposphere, okay, all weather phenomena happens here. I will just add into this diagram. I will whatever I have studied, I will try to summarize in this diagram. Okay, see, now the question is, which of the followings help in wireless communication? Anyone would like to answer? We already discussed stratosphere, mesosphere, ionosphere, exosphere. Which of the following layers helps in wireless communication? Any student, please, would like to answer? You can even type also. When you're typing, make it public so that everyone can see. Anyone would like to answer, please? Is it that difficult? Which of the following layers help in wireless communication? Just now I taught. Anyone, any student? Come on, participate. Or should I explain again?
Ionosphere.
It is correct. It's an ionosphere. Okay, radio waves goes and come back. This is how we most of the communication technology we are using it. Okay, see, UPSC or any state government examination does not want us to go into the technical details. So we will not fall into a trap. Okay, we will see, okay, how the radio waves is going and coming back. We have to remember that, okay, this is the layer from which the radio waves is coming back, and this is used in, because of this radio wave, people are using it in the communication technology. Okay, good, very good. Consider the following statement regarding troposphere. Okay, climate and weather is present in this layer. Okay, we are talking about troposphere. Then height of troposphere is more in tropics than poles because of advection. In troposphere, temperature decreases with height. How many statements are right? They are asking how many statements are right. Okay, they are not asking which of the sentence is right. They are just asking how many statements are right. Any student? We have studied about troposphere. Okay, we already discussed, yes, climate and weather is present in this layer. We already discussed most of the climate and weather is present in this layer. Okay, then the height of the troposphere is more in tropics than poles because of advection. Okay, we will discuss what is advection, what is convection, what are these things we will discuss. Okay, in troposphere, temperature decreases with height. Okay, third statement is also true. Okay, because in troposphere, temperature decreases with height. Okay, in stratosphere, temperature increases with height. In mesosphere, again temperature decreases with height. Then in thermosphere, again temperature will increase with height. Okay, we have to remember this diagram. Okay, try to summarize whatever we study into this diagram, then it will be very helpful, and it has been helpful in real examination for me. Now we have studied what is climate, what is weather. Now what is season? Okay, no matter whatever we say to season, the technical definition of season is there is a way, because of the variation in day and night, the season happen, and there are 4 types of season. If we talk about, there are winter, spring, summer, autumn. These kind of 4 seasons are there. Okay, why this season is happening, why winter is happening, why summer is happening? Because in the variation in day and night, and the variation in day and night is happening because of the revolution and rotation of the earth. Okay, the variation in day and night is happening because of the revolution and rotation of the earth. And one more reason, because why variation is happening, because the earth is tilted. Okay, the earth is little bit tilted. If you will see earth now, the earth, see, the earth is tilted. The earth, geographical north pole and south pole is not straight. Okay, it is little bit tilted towards the sun. Okay, so before going to like, if before seeing, okay, season, or the, because how the variation in day and night is happening, we should know the major latitudes. Okay, I hope you might remember this in your childhood. You might have studied this in your school days. You might have studied this. The center one is called as equator. Okay, equator means there is a 0 degree line. Okay, this 0 degree means in terms of latitude and longitude they are saying. Okay, 0 degree. Okay, this is not about temperature, 0 degrees Celsius or anything. This 0 degree is about the direction. Okay, then there is Tropic of Cancer line above and Tropic of Capricorn line below. Okay, this line is at 23.5 degrees. Okay, both 23.5 degree north, 23.5 degree south. Okay, and then above it, it is 66 degree north Arctic line and 66 degree south Antarctic line. Okay, the region between Tropic of Cancer and equator is called as, or the region between Tropic of Capricorn to Tropic of Cancer will be called as the tropical region. Okay, the region from Tropic of Cancer to Tropic of Capricorn will be called as the region from Tropic of Cancer to Tropic of Capricorn will be called as a tropical region. The region between Tropic of Cancer to Arctic Circle is called as temperate. Similarly, the region between Tropic of Capricorn to Antarctic Circle will be called as temperate region. So the orange region is called tropical region. Okay, the green region is called as temperate region, and the purple region will be called as the polar region. I hope you remember your basics.
Please, sir. Take
What?
one more explain.
One more time, this latitudes.
Yeah.
Okay. So the center line is called as equator, or the central, the dark red color region. Okay, it will be called as the equatorial region. Okay, it will be called as the equatorial region, and it is part of tropical region also. So the region between Tropic of Cancer to Tropic of Capricorn, okay, or the region which is in orange color will be called as orange or peach. You can also consider as a peach color. It is a very light orange color, peach color. This peach color is the region of tropical region. Okay, India lies in this tropical region. Okay, India lies in this tropical region only. This is the shape of the earth. Okay, so then the region green in color, it is called as temperate region. This is the region where the Europe, lies, or where the United States of America is in this region. Okay, then the purple color region is called as polar region. Okay, the purple color region is called as the polar region. So there are three the if you will divide the earth, it is divided into three parts: tropical area, temperate area, and polar area. Okay, understood?
Yeah, thank you.
Okay. So see, normally we know ki sun is in the center of our solar system, and all the planets revolve around the sun. Okay, so the way all the planets revolve around this earth also revolve around the sun. So when it is revolving, it is not revolving in a proper circle. It is revolving in a ellipse. Okay, if you will see the distance between this distance between the sun and earth in this direction, it is low. But if you will see the distance between sun and earth in this direction, it is more. Okay, so and if you will see, this is not a perfect circle. The way it is revolving around the earth is the revolving around the sun, it is not a perfect circle. It is a ellipsoid. It is called as ellipsoid or ellipse. Okay, so on March 21 to 22 degree, on March 21 and 22, either one of the March 21 or 22, or the September 23, 22 or 23. Okay, means see, if we will divide our year into three months, okay, then we will see. Okay, first will March 21 to 22, where the earth is called as at equinox. Okay, similarly, on September 22 to 23, the earth is also at equinox. What is the meaning of equinox? Both day and night will be 12 hours everywhere. Everywhere on the earth, the day and night will be at the 12 hours. And it is in when the earth is at this position on March 21 to 22 and September 22 to 23, at this time, the earth is in such a way that it looks like there is no tiltation. Okay, I said na, the earth is little tilted, but there is no tiltation. Okay, so it looks like the earth is very straight to the sun. So here the date is 12 hours and night is 12 hours. It is called as equinox, equal day and equal night, equinox. Similarly, if you will see after coming to March 21 to 22, the very next time on June 21 to 29, after 3 months. Okay, March 3rd month, then again 6th month. Okay, when we will see the 6th month, year the earth is tilted, the northern hemisphere of the earth is tilted towards the sun. Okay, the northern hemisphere of the earth is tilted towards the sun, and here India is also part of northern hemisphere, and India will have a summer. Okay, and because of heat also, there is rainfall also in June. Okay, so just to remember, when the earth is tilted towards when the northern hemisphere is tilted towards the sun, it will be called as summer solstice. Okay, summer solstice. The solstice is written solstice June 21 to 22. Why they have written solstice, not summer solstice? Because for northern hemisphere it will be summer solstice, but for southern hemisphere it will be winter solstice. Okay, you might have heard that the Australia is in the southern hemisphere. Okay, on 25th December. Okay, so now June is over. Now let's we also discuss this September 22 23. It is also equinox. Now this December 21 and 23. Okay, when we are talking about the month of December, the southern hemisphere is tilted towards the sun. If the southern hemisphere is tilted towards the sun and the northern hemisphere is away from the sun, means the southern hemisphere will have a more solar energy and there will be a summer. And because the northern hemisphere is away from the earth, okay, it will have a winter. This is the reason why, and India lies in the northern hemisphere, and this is the reason why we have one of the reason why we have winter in the December month. But you know, not only us, even the most of the European countries will have we'll have winter or we'll have snowfall in December. But when we talk about the Australia, other areas like America and Europe are celebrating Christmas in winter. But Australia, because it lies in the southern hemisphere, Australia will not have a winter in the Christmas. Australia will have a summer in the Christmas. So the Australian people celebrate Christmas on 25th December in summer. Okay, I hope you might have been able to understand a little. It's a little complex idea, but I hope you might have understand. Or obviously, when on 22nd December, because there is a summer in the southern hemisphere, who will have the long daytime? Southern hemisphere or northern hemisphere? Hello? Anyone would like to answer? In the month of December, southern hemisphere will have long days or northern hemisphere will have long days? Summer, whenever there is a summer, there is a long day. Whenever there is a winter, there is a long night.
Night.
If you are clear with this small concept, na, even if they ask some complex question, you will be easily able to ask. You will be easily able to answer that question. See, variation in the length of daytime and night time from season to season are due to. So we already discussed why there is a variation in the length of daytime and nighttime, because the Earth's revolution around the sun in an elliptical manner. Because they are revolving around the sun in an elliptical manner, sometimes it is closer to sun, sometimes it is very far away from the sun. When it is closer to the sun and when it is farthest from the sun, there will be some differences. Okay, when it is farther from the sun and plus in an elliptical manner. Okay, so because of this, there is a variation in the length of daytime and nighttime. And one more reason I said, though they have not, sorry, they have given it. Okay, revolution of the Earth on a tilted axis. Okay, so in the B, they have only talked about revolution. In the option D, they have talked about the revolution of the Earth on a tilted axis. So we have to remember why there is a variation in the length of daytime and nighttime, because of revolution of the Earth as well as because of the revolution of the Earth on a tilted axis. Okay, so because of the tilted axis, sometimes northern hemisphere is towards sun, so therefore northern hemisphere will have long days, and sometimes southern hemisphere will be tilted towards the sun. That time the southern hemisphere will have long days. Okay, understood? Hello? Hello?
Yes, sir.
Yeah, okay. So the next question is, in northern hemisphere, the longest day of the year normally occur in. See, now answer this question. Okay, they are asking in the northern hemisphere, the longest day of the year normally occurs in the first half of the month of the June, second half of the month of the June, first half of the month of the July, or second half of the month of the July. See, we will cancel directly July. Okay, now we have only two options: first half of the month of June or second half of the month of June. So we see when summer solstice is happening. Okay, summer solstice is happening in the 21st of or 22nd of June. Okay, I hope you also know that on in India we celebrate the yoga day, or International Yoga Day is celebrated on 21st June, and this is the reason why we celebrate. Summer solstice is there, a full day. We have the longest day, okay, of the longest day of the year in the northern hemisphere on 21st June. Okay, this is the reason why we celebrate International Yoga Day. On the longest day, we should do yoga. So the second half of the month of June, because 21st till 15, the first half of the month of June. After 15th of June, it will become under second half of the month of the June. Then it is 21st of June when the summer solstice is happening. Okay, so when we were discussing that, I said that Okay, during March, okay, just third month of the year, there will be equinox. Okay, in this equinox, each day and each night will be of equal length, that is 12 hours on March 21. Any place on the earth, if you will see on March 21, they will have 12 hours of day, 12 hours of night. Now, when we talked about summer solstice, then the largest day or the longest day will be on the 21st June in the northern hemisphere. But see, when I am saying in the northern hemisphere there is a longest day, it automatically means in the southern hemisphere there will be a longest night. Okay. Now coming to September, on September 22 or 23. Okay. So on September 22 and 23, maybe on 22 or maybe on 23 or maybe even on 21 also, there will be a day where the day and night will be of equal length, 12 hours of day, 12 hours of night. Now coming towards the December month. In December month, the longest day will be in the southern hemisphere and the longest night will be in the northern hemisphere. Okay, go in geography, more than reading, you should see the diagrams for your better understanding. See, they again have given on 21st June. Okay, on 21st June, the sun does not set below the horizon at the Arctic Circle, does not set below the horizon at the Antarctic Circle, shines vertically overhead at noon on the equator, shines vertically overhead at the Tropic of Capricorn. Okay, I will not answer this. I will explain what the statement is trying to say. Okay, before explaining this, one more things I want to say you. Okay, I don't know whether you know this or not. Some people might have thought, okay, this is just a fake or something like that, but there will be continuous 6 months of day and 6 months of night, continuous 6 months of day and 6 months of night in the North Pole and South Pole. Okay, normally we have in India sometimes 16 hours, 17 hours, okay, or normally 14 to 15 hours of daytime and the remaining night time. But as we move upwards to, or as we go downwards, the daytime will decrease and the night time will increase. Or so when we reach to the northern pole or south pole of the earth, there will be continuous 6 months of day and 6 months of night. Okay, this is one phenomena. So means the sun is not setting there. Okay, when we are sleeping, when a lot of areas in the earth, region in the earth have a dark time, they are not having a dark time. So see, if you will see this diagram, when the earth is tilted towards the earth, when the earth is tilted towards the sun, the upper part, the northern part is full of sunlight, so there is day. And if you will see the southern part or south pole, the south pole, it is under dark, there will be a night. Okay, and this night and dark will be there for continuous 6 months. So coming back to this question, on 21st June, the sun does not set below the horizon at the Arctic Circle. It means does not set below the horizon at the Arctic Circle means it is saying that, okay, there is sunlight. Okay, there is sunlight in the Arctic Circle. Then they are saying the sun does not set below the horizon at the Antarctic Circle. Means they are saying there is also light in the Antarctic Circle. They are saying third option, that the sun shines vertically overhead at noon on the equator. Okay, then they are saying shines vertically overhead at the Tropic of Capricorn. These things they have said, but the sun will shines vertically. If you will see, okay, the sun on 21st June, see, the sun is shining vertically on the Tropic of Cancer, not on Tropic of Capricorn. So our shines vertically over at the Tropic of Capricorn is wrong. Shines vertically over at the noon on the equator is also wrong. Because on 21st June, okay, see this. On 21st June, the sun rays is coming and is directly overhead over Tropic of Cancer. Okay. So at this time, option number C and D is wrong. And it is said that sun does not set below the horizon at the equator, Antarctic Circle, C. But here, if you will see Antarctic Circle, there is no sun only. So the sun has set below. Okay, so the option A, see here, option A, when we see Antarctic Circle, here the sun rays are there. It is in the light, not dark. Whereas Antarctic Circle is in dark portion. So our answer, this is very good. The person who has made this question has a very in-depth understanding of the topic. On 21st June, the sun does not set below the horizon at the attack. So A will be the answer. So if you have that level of understanding, only that you will be able to mark this. Otherwise, see the question number 1 and 2, when we solved the above two question, it was easy. The third question was tough, technical. But if you mark this answer right, of if you understood this question, then no matter how much technical question next time the person is going to make, you are going to mark it right, correct. Okay. I think let's done for the day. Is Shahid sir going to continue? Hello, Tanvir sir.
Yes, Mr. Sahir is going to continue.
Should I stop or
Just
should I continue?
you continue till Mr. Sahir is ready.
Okay. But we have to give some 10 minutes break to students also. But I will continue. We will give some 10 minutes break and Shahid sir can continue. Okay. Okay. So the next topic is about the how the earth gets heat up. Okay, now whatever we understood, the solar radiation is coming, there is a variation in daytime, nighttime, the climate is there, atmosphere is there. Now the most important aspect is how the earth gets heat. Okay, most of us think because of the solar radiation is coming into the earth, the solar radiation is making the earth heat. But this is wrong. It is not the solar radiation directly making the earth heat. Okay, we will study how the earth is getting heat. Okay, so some of the factors controlling the temperature distribution. Okay, I think this we will see later on. First, we will see how the earth gets heat up. Okay, so earth receives solar radiation. Okay, solar radiation, S for solar radiation or S for short waves. Remember, the solar radiation are short waves. It will come inside the earth, and these short waves will be absorbed by a lot of things, but mainly our focus is by the earth surface. Earth surface will absorb it and will convert its solar radiation into long wave terrestrial radiation. Okay, this long wave terrestrial radiation or long waves or terrestrial radiation, either one word also you can use just long waves or you can just use terrestrial radiation also. Okay, when the solar radiation came inside the earth, the atmosphere does not get heated up because of it. It got heated very little. But when the heat came inside, when the solar radiation came inside the land on the earth, okay, when we talk about the land surface, not land, okay, let's say the surface of the earth, okay, because even the water is also part of that surface. So the surface of the earth, what it did, it absorbed the solar radiation. And once something will absorb heat, and after that it will start to radiate heat. Okay, for example, if we say, okay, metal, first the metal will, if you put your metal inside the fire, it will not make your hand burn, but first it will absorb heat. Then after one point of time, it will also transfer heat, or it will start radiation heat. Then you will feel, okay, it's hot, then you will not touch. Similarly, when the solar radiation is coming inside the earth, what it is going to do, it is going to make the land absorb that solar radiation. The land will absorb, surface will absorb the solar radiation, And after that solar radiation is fully absorbed, at one point of time, the Earth's surface will start to radiate back heat. When the Earth's surface is radiating back that heat, it is radiating it in the form of long waves. And as we already studied, there are some gaseous water vapor in the atmosphere. Okay, when we see the composition of atmosphere, there are some gases, greenhouse gases, carbon dioxide, methane, and water vapor. These kind of things are there in the atmosphere. When the Earth radiates heat back, long wave, then they will absorb that. And when they absorb it, that it will act like a greenhouse gas, and they will heat up the atmosphere. Okay, and just to remember these short waves and long waves, I will just give you one thing. Okay, because it is coming from sun or solar, so short waves. S for sun, S for short waves. Because of the long wave is coming from the surface or land. To remember land, so land, L for land, L for long wave. Just remember that. Okay, sometimes because when the question is coming, they will change short waves into long waves, and they, instead of long wave, they will use short wave. This is how they will make wrong statements. Okay, so just to remember that, S for solar, S for short waves. Okay, so the sun or solar energy is the short waves. Okay, but the short waves are high energy waves. Actually, short waves are high energy waves. Long waves are not that high energy waves. So land, L for land, L for long waves. I hope you will remember this. Okay, see, when we are studying, we have to study a lot of things. So come up with this kind of small you can say illogical or non-sensible shortcuts, but it will be helpful in the end. It will be helpful for you to just to remember it very quickly. Okay, so now you will remember, the Earth is not getting heat up, the Earth's atmosphere is not getting heat up because of this solar radiation. It is getting heat up because of the solar radiation or solar insolation coming inside the Earth is getting absorbed by the Earth's surface or Earth's land. Then that radiation is reflected back in the form of long wave radiation, terrestrial radiation. Okay, a lot of things are getting, I think you are getting new things like six months of day and 6 months of night. And normally we will think the temperature will decrease as we will go up, but that it will only decrease till troposphere. Then again stratosphere, there will be increase in temperature. Are you getting new concepts? Lot of, hello, or you already know all
Yes,
these things?
yes, sir.
Okay. If you already know, it's very good. See, now there are three waves of energy
Sir,
transfer.
can you break now?
You need break?
Yes, sir.
Can you give me more 8 minutes? I just want to explain these three concepts. Okay, just this
Okay.
2 pages. Okay, please. Okay. After me, my lecture will end after some 7-8 minutes. Then the Shahi sir will continue. Okay. So how the heat is transferred? Okay, one is radiation. Okay, radiation, and the very good example of radiation is sun. Okay, sun is a very hot body and it radiates heat. Okay, this is called as radiation. Okay, sometimes in winter you will see people burning wood and going near it, and going near that burn wood just to get warm from it. Okay, it is also a type of radiation. Okay, then there is conduction. In this conduction, heat is transferred from one body to another body through contact. Okay, through contact. Okay, so the example I gave, that you will take a spoon, and while you are cooking food, if you will put that spoon inside that utensil or that cooking utensil, then slowly your spoon also will become hot. This is the conduction, where one body is transferring heat to another body. Okay, then there is convection. Okay, this is very important. This is the thing which we will be using. Okay, even if you forget radiation conduction, doesn't matter, but they can make question on radiation conduction. but the convection is the concept where you will be using it everywhere. Okay, here the transfer of heat energy by actual transfer of matter or substance from one place to another. Okay, so here the trans the heat the heat is transfer the heat which is transferring from one matter to, it is not transferring from one matter to another, but the one matter is transferring heat throughout everywhere. For example, a hot water. Okay, a hot water can transfer, and if it move, it will take hot water with itself everywhere. Similarly, a hot wind, when a air or wind is blowing, so that time if it's hot or it's warm, it will take that heat or warmness with it everywhere. Okay, and this phenomena is called as convection, and the thing which I mentioned about wind is the concept which we will be using a lot, because the atmosphere after getting heat up will exchange heat from one region to another region using air or wind. Okay, wind is nothing but a simple definition of wind is a moving air, a horizontal movement of air. Okay, a horizontal movement of air is called as wind. Okay, a wind which is air which is not moving at one place, it will not be called as a wind. As soon as the air started to blow or wind, as soon as the air started to blow or move, it will be called as a wind. So convection, what is the meaning of convection? The transfer of heat is by actual transfer of matter. In this, the matter is air or wind. Okay, this is how one place, if, for example, polar region, though they are very little, or in temperate region very little solar radiation is coming, but still, because tropical is having abundant supply of solar radiation, it will transfer the heat from one area to another area via wind. Okay, via transfer of matter. I hope you understood this concept. Okay, especially convection, you have to remember, because it will be used at multiple places. Climatology is a very conceptual question. If you have to understand each and every concept, then only you will be able to understand a lot of things. Okay, done. Understood everything? Any question? Anyone? Any question? Anyone? Any question?
No, sir.
No. Okay. 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 Fine. So
Thank you, Sarfaraz, for your
yeah.
class today. And we will be going on a break for another 13 minutes, and we'll be back by 3:15 for the next agenda of the meeting.
Hmm.
But please do not log out. Keep that login, and then you can go for a break. Thank you. Thank you very much.
Sir, should I make you again host?
Yes, please do that. I'll make a Shahir if he joins.
Okay. 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 Sir, can you raise your hand, sir?
Falcon Academy.
Okay, Falcon Academy.
I can reclaim. I claimed it.
Oh, you claimed it. Okay. Okay. Fine. Fine. Okay, sir.
Thank you very much. Thank you, Sarfaraz.
Okay, sir. Thank you, sir.
Mr. Shahir Sharif, I have made you co-host. We'll be starting our next session at 3:15. So people are in the break session now.
Okay, sir, we can start at 3:15. So hi everyone, is my screen visible? Can someone respond?
Yes, it is visible.
Okay, fine, good.
Shall we start the class? It is 3:15. I request audience to say, raise the hands who are ready for the classes, please.
Yes, sir.
Any other persons? Everybody is there?
Yes.
I didn't get any response from institutes. Yes, Mr. Syed, please go ahead.
Okay. So I hope like we can start the class. So in the last class, we have discussed some of the basic operations that we conduct in the number system. Okay, so from here in this class, we are starting from where we left off in the last class. And in this class also, we will be continuing with some of the basic operations. Okay, so we'll be going with the basic operations that we should know. And this is like fundamental for every examination, not just the UPSC. And for all other competitive examinations, this is like a very fundamental knowledge that you should have. And we will continue with the same thing. Okay, so the first thing you should know that in the last class, we have discussed about the factors, the multiples, etc. So I hope like you remember the factors. Okay, so simply the factors means I'm just taking a recap. Okay, because if you want to continue with today's class, you should be thorough with what is factors. Okay, so what was factors? So factors is like if there is a number, say for example, there is a number like 12. So the factors means whichever number that can divide the 12, these numbers are called the factors of 12. Say for example, there is 2. If I divide 12 by 2, I will get 6. Okay, the same way if I divide 12 by 3, I will get 4. The same way 12 divided by 4, I will get 3. So all these numbers like 1, 2, 3, 4, 6, 12, all these are the factors of 12. Okay, so this is the concept of the factors. Whichever number can divide a number is considered as a factor of that particular number. Okay, so to go for a definition, if there is A and B can divide A without a remainder, then B is a factor. Okay, so then B is a factor of A. So this is the definition of factor. Okay, so this is what we have learned in the last class. So in this class, we will go for divisibility rule. So many times in the examination, they ask like they will give a random number and they will ask like whether the 3 can divide this particular number. So you should know what is the basic rules to check the divisibility of a particular number with 3. Okay, so it's very easy. Say for example, there is a number like 6, 2, 1, 3, 4, 5. Okay, this is a huge number, a large number. So you want to check whether this particular number can be divided by 3. So what you should do, you just have to add individual numbers. Okay, so here the individual numbers are like 6 plus 2 plus 1 plus 3 plus 4 plus 5. Okay, so what you will get? 6 plus 2 plus 1, that is 9. 9 plus 3, that is 12. 12 plus 6, that will be 16. 16 plus 5 is equal to 21. So the sum of the digits of this particular number, okay, this particular number, the sum of the individual digits of this particular number is equal to 21. Then check whether this number can be divided by 3. Okay, can we divide 21 by 3? Yeah, you can respond. Can we divide 21 by 3?
Yes, sir.
Yes, exactly. So 21 by 3, that is equal to 7. So which means that this particular number 6, 2, 1, 3, 4, 5 can be divided by 3. there is no need for you to check it with dividing this particular number. So whichever number you get, you just add that number and you will get a sum. And if that sum can be divided by 3, then that particular number also can be divided by 3. Okay, so you can check with the different numbers. You can take some random numbers and check whether it is divisible by 3 or not. Okay, so just do this thing, okay, as a homework to improve your skill. Just take some random numbers and add their individual digit and check whether they can be divided by 3. Okay, so I can take like some other numbers also. Say for example, like 7, 3, 5, 2, 1. Okay, so I want to check whether this can be divided by 3. So what I will do, again, I will add these numbers. 7 plus 3 plus 5 plus 2 plus 1. So 7 plus 3 is 10. 10 plus 5 is equal to 15. 15 plus 2 is equal to 17. 17 plus 1 is equal to 18. So 18 divided by 3, this is equal to 6. So as I can divide this 18, that is the sum of the individual digits of this particular number. I can divide this particular number also, this particular 73, that is 73,523. So I can divide 73,521 with 3, because if I add the individual numbers, I will get 18 and I can divide the 18 by 3. Okay, so this is the divisibility rule for 3. So I think like this is very much clear to you. Just remember this. We will be using this to solve the advanced problems when we go ahead. Okay. Now comes the divisibility rule for 4. So the same way, there will be some random numbers. They will be giving it to you and they will ask whether this particular number can be divided by 4 or not. They will be asking the same question. So again, you should know what is the method to find whether I can divide a particular number with 4 or not. So here also, you have to do one thing, that is, if the number is divisible by 4, then the number formed by its last 2 digit, just check whether the last 2 digit is divisible by 4 or not. Okay, so I will just give you a random number, 9356764, some large number. So I don't know whether I can divide this particular number with 4 or not. So I want to check whether I can divide this particular number with 4. So what I will do, I will just go for the last 2 digits. This last 2 digits. Okay, that is 64. Then I will divide 64 by 4 and that is equal to, so can someone tell me whether I can divide 64 by 4? Can I divide? So are you guys there? So can I divide 64 by 4 or not?
Yes, sir.
Yes, I can divide, because 64 is simply like 40 plus 24 divided by 4. Just think this way. Okay, if you don't know whether you can divide 64, just consider the nearest term which is divisible by 4. That is 40. Okay, so 40 plus the remainder or the like whatever the number is left over, that is 24. So 40 I can divide, that will be 10. And 24, that is 6. Okay, so the answer is 16. As I can divide the 64 by 4, this number is also divisible by 4. Okay, this number 9356764 is also divisible by 4. Okay, so I will take another number so that it will be more clear to you. Okay, so I will check the same with another number. Just let me erase this. Okay, so I'm taking another random number, that is 754312 Okay, or like 42. Okay, so I just want to know whether I can divide this particular number by 4. So it will be very difficult if you go and divide this number, like to check whether it can be divided by 4 or not. So what I will do, I will just check the last 2 digit. That is, so here the last 2 digit is 42. Okay, so here the last 2 digit is 42. So I will take the 42 and I will divide by 4. So as we have done earlier, it will be like 40 plus 2 divided by 4. So I can divide 40 by 4. There is no issue with it. I will get 10. but there is a remainder 2. So if I divide 42 by 4, I will get a remainder 2, isn't it? So I will get a remainder 2. So which means that I cannot divide this number by 4. Okay, so if I divide this particular number, I will get 2 as a remainder. I will get 2 as a remainder. So I cannot divide this particular number with 4. Okay, so I hope that this concept is very clear to you. So for the 3, to check the divisibility by 3, you just added the individual numbers. And to check the divisibility by 4, you have to consider the last 2 digit. If the last 2 digit is divisible by 4, then it is also divisible by 4. Okay, and if it is not divisible, if there comes some remainder, then that will be the remainder if I divide this huge number with 4. Okay, so that is the divisibility rule for 4. Now, coming to the divisibility rule for the 5. So it is very easy. If you want to know whether I can divide a particular number or whether you can divide a particular number by 5, then it is very easy. Just check the last digit. If the last digit is 0 or 5, then you can divide. Okay, so if the last digit is 0 or 5, say for example, if it is like 100, or if it is like 115, or like 255. So in all this case, the last digit is either 0 or 5. So it's very easy for me to divide with 5, or each of these numbers are like the multiples of 5. So for example, 100. 100 is equal to 5 into 20. 150, this is equal to 5 into 23. Okay, then 255. This is equal to 54. Sorry, 55, I think, into 5, isn't it? Sorry, 51. Okay. 51. So 51 into 5 is equal to 255. So likewise, each of this number is a multiple of 5. So if the last digit is either 0 or 5, I can divide that particular number with 5. So this is the divisibility rule for 5. Now coming to the divisibility rule by 6. Okay, so this is also very tricky. Okay, the divisibility rule by 6. So in order to check the divisibility by 6, you should check the divisibility by 2 and 3. Okay, if there is a particular number and I can divide that particular number by 2 and 3. Okay, so if I can divide a particular number with a 2 and 3, it is not like 2 or 3, it is 2 and 3. I should be able to divide that particular number with both 2 and 3. And if I am able to do that, then it is also divisible by 6. Okay, so how we will check the divisibility by 2? How we will check the divisibility by 2? It is easy. Okay, so in order to check the divisibility by 2, you just have to check whether it is an even number. Okay, if it is an even number, then definitely it is divisible by 2. Okay, then to check whether it is divisible by 3, you just have to add each individual digits and check whether the sum is divisible by 3. So you have to do 2 calculation, or like 2 things. First, you have to check whether it is divisible by 2. The second, whether it is divisible by 3. If it is divisible by both 2 and 3, then it is divisible by 6 also. Okay, so this is how we will check the divisibility by 6. Okay, so you can take any number. Say for example, like 126. Okay, so as the last digit is an even number, 126 is also an even number. Okay, so this is also an even number, which means that this number can be divided by 2. Now I want to check whether I can divide this particular number with 3. So for that, I will add the individual digit. 1 plus 2 plus 6. This is equal to 9, and I can divide 9 by 3. That is equal to 3. So 126 is divisible by 6. Okay, so I can divide 126 by 6. And the answer will be 21. Okay, so it will be easily divisible. So this is the way, this is the method to check the divisibility by 6 also. Okay, now come to the divisibility rule for the 7. Okay, So the divisibility rule for the 7 is slightly different from what we have studied till now. So for this, you have to check whether, like, in order to check whether a number is divisible by 7, okay, you have to double the last digit and subtract it from the rest of the numbers. So here it won't be that easy. Say, for example, if the number is like 203 as it is given here, okay, so it is 203. So I just want to check whether this is divisible by 7 or not, whether I can divide 203 with 7. So what I will do, I will find the last digit. The last digit here is 3, and I will double it. So 3 into 2, that is equal to 6. So I just doubled the last digit. Now what I will do, I will take the remainder, that is 20 minus 6, that is equal to 14. Okay, now I will check whether I can divide this 14 by 7 or not. So I can divide, it is equal to 2. Okay, so this means that 203 can be divided by 7. This is true. Okay, so I can divide 203 by 7. So what if it is a large number? So this is like a small number, so it was easy for me. So what if it is a large number? Then how I can check whether I can divide that particular number by 7 or not? So I will take another example. 55231. So here also you should follow the same principle, the same method. You will consider the last digit. Here the last digit is 1. So you have to double that, that is equal to 2. Then you have to subtract it, 5523 minus 2, that is equal to 5521. So here also it is difficult for you to check whether it is divisible, whether I can divide 5521 with 7 or not, because this is a 4-digit number. So again, you have to repeat the same thing. Here also you have to consider the last digit, that is 1. Then you have to double it, that is equal to 2. Then 552 minus 2. Okay, so here what I will get, 550. So here also you don't know whether it is divisible by 7 or not. Then what you will do, you will consider the last digit. Here it is 0. So just double it, then also it will be 0. Then 55 minus 0, that is equal to 55 itself. Okay, so is 55 divisible by 7? No, because if it is 56, then if I divide it, then I will get 8. So 55 is not divisible by 7. Okay, 55 is not divisible by 7. Because of that, this number is not divisible by 7. Okay, so it's simply like you have to repeat the process again and again. If it is a large number, just repeat it. Once you are like acquainted with this particular thing, once you practice it more, then it will be easy for you. You don't have to go through all the steps. Repeatedly doing again and again, you don't have to do it. You can do it like very easily. By some like mental calculation, you will be able to find the answer very easily. Okay, so you just have to practice this, then it will be easy for you to just look into this particular number and tell whether you can divide this by 7 or not. Okay, so this is the divisibility rule for 7. Okay. Now just check this particular number. This is 2499. So we want to check whether this number can be divided by 7 or not. 2499, whether it can be divided by 7 or not. So what you will do here, 2499 is there. So the last digit is 9. Okay, so the last digit is 9. So you will double the 9, that is equal to 18. And the remaining is like 249. You will subtract this 18 from here. So what you will get to? You will get 231. Okay, but you don't know whether 231 is divisible by 7 or not. Then what you will do? You will take the last digit. Okay, so you will double it, that will be 2. Then you will subtract it from 23. The remaining digits, that is 23, and this will be equal to 21. So I can divide 20 by 1, 7, that is equal to 3. Okay, so what it means? It means that 2 2499 or like 2499 can be divided by 7. Okay, so this I can divide by 7. So this is how you should check the divisibility by 7. Okay. Now, coming to the next divisibility rule, that is 8. Okay. So for the 8 also, just like the 4, when it was 4, what we did was, okay, when it was 4, to check the divisibility by 4, what we did was, we just take the last 2 digit. Say for example, 5332. We just take the last digit and check whether I can divide this 32. If I can divide 32 by 4, then I can divide 5332 by 4. This is what we have done. So in the same way, here also for the 8, you have to consider the last 3 digits. Okay. So here the last 3 digits you have to consider. And if I can divide the last 3 digits, then I can divide that particular number also. So I will take a random number, 352132556. Okay, so I don't know whether I can divide this particular number by 8. So I just want to check whether I can divide this particular number by 8 or not. So what I will do, I will consider the last 3 digits, that is 256. So I will check whether I can divide 256 by 8 or not. Okay, so how you will check that? You can consider the first 2 digits. Okay, that is 25. So 24 is divisible by 8. Then the remainder will be 1. Then it will be 16. Okay, it is like 2416. Okay, so it is like 240 plus 16. So the 24 I can divide by 8, 16 also I can divide by 8. So which means that 256 can be divided by 8. So what it means? It means that 3521326, this number can be divided by 8. Okay, so this number can be divided by 8. So this is the way, this is how you have to check the divisibility by 8. Okay, so is the concepts clear? So were you able to follow this? Are you able to follow this?
Yes.
Okay.
Yes, sir.
Okay, good. So this is the divisibility rule or the criteria for 8. Okay. Now let's move to 9. So for the 9 also, the criteria is same as the 3. So what was the criteria for 3? So for 3,
Add all the
add all the individual digits
numbers.
and check whether the sum is divisible by 3. Okay, good. So that we have to do here also. So you have some random number. So for example, like 9187218. So you don't know whether you can divide this particular number by 9 or not. So what you should do, you just have to add all the digits. So here I am adding all the digits, 9 plus 1 plus 8 plus 7 plus 2 plus 1 plus 8. So this is the sum. So while adding, I will get 9 plus 1, 10, 10 plus 8, 18, 18 plus 7, 25, 25 plus 2, 27. Then 27 plus 1, 28, 28 plus 6, that is equal to 36. Okay, so 36 is easily divisible by 9, and I will get what? I will get 4. So it means that this particular number is divisible by 9. Okay, you can observe the same pattern. If you go through the multiples or the multiplication table of the 9, you can find the same pattern. So it's like 1 into 9 is equal to 9. 2 into 9 is equal to 18. 3 into 9 is equal to 27. 4 into 9 is equal to 36. 5 into 9 is equal to 45. So likewise it goes. So you can see like 1 plus 8, this is equal to 9. 2 plus 7, this is also equal to 9. 3 plus 6, this is also equal to 9. 4 plus 5, again this is equal to 9. Okay, so it's very simple. Just add each of the number and check whether I can divide that particular number by 9. If I can divide that particular number, then it means that I can divide that large number also by 9. Okay, so this simply means that 9187218 is divisible by 9. Okay, so this is divisible by 9. Okay, so this is the divisibility rule for 9. So this is like a previous year question that is asked in some SSC examination. So they have simply asked it, which among the following number is divisible by 9? Okay, so if you know the divisibility rule for the 9, you can just check the numbers.
Option C.
Yeah, option C. So it's like if I consider the first number, it will be like 1 plus 4 is equal to 5. Then 5 plus 5 is equal to 10. 10 plus 7 equal to 17. No, I can divide this by 9. Now consider the second option. 3 plus 4 is equal to 7. 7 plus 7 is equal to 14. 14 plus 1 is equal to 15. Divide by 7. No, it is not possible. Now considering the D option, 4 plus 7 is equal to 11. 11 plus 9 is equal to 20. 20 plus 5 is equal to 25. Divided by 9. No, it is not possible. Now considering the C option, 5 plus 9, already it is 9. Then 1 plus 8, already it is 9. So 9 plus 9 is equal to 18. Divided by 9, this is equal to 2. So the answer is this one. So it won't take any time. You can just look into the options and you can mark the answer. It is that easy. Okay, if you get the hang of solving these problems, you can easily mark the questions with the right answers. Okay. Now coming to the next, that is divisibility by 11. This is the maximum that can be asked in a particular examination. They won't ask more than this. They won't ask like whether a particular number is divisible by 13 or whether a particular number is divisible by 17. So this is the maximum that they can ask, up to 11. Okay. So for the 11, what you have to do is that here it is a bit different. You have to sum the digits in the odd position. You have to sum the digit in odd position and subtract that particular from the sum of its digits in even position. And you will get a number. And if that particular number is divisible by 11, then that particular number is also divisible by 11. Okay. So for example, there is 2, 7, 2, 8. So you have to find the sum of the numbers in the odd position. That is 7 and 8. So if I add 7 plus 8, I will get 15. Now considering the numbers in even position, that is 2 and 2, I will add that also. So I will get 4. Now what I will do, I will subtract this. That is 15 minus 4, that is equal to 11. So as I can divide 11 by 11, this particular number 2728, okay, this particular number is also divisible by 2. Sorry, it is also divisible by 11. Okay, so this is also divisible by 11. So it simply means that 2728 is divisible by 11. So likewise, you can check the divisibility for any number. Okay, with 11. So till this, you have to learn, because I skipped the divisibility by 10 because any number with the last digit as 0 is divisible by 10. So that is an easy task for you. That's why I didn't take up that topic. Say for example, if it is like 520, if the last digit is 0, obviously it can be divided by 10. Okay, so that's why I skipped the divisibility by 10. So the rest all the digits, or like the rest all the numbers starting from 3 to 11, you should remember the divisibility rules. Okay, so we will be sharing the PDF in the group. So you can go through this once again if you have any doubts, and just practice with some random numbers so that over the time you will develop the skills in the maths. So whenever you get a particular number, you will be able to like just look into it and say whether it can be divided by like 3, whether it can be divided by 7, whether it can be divided by 9. So that skill you have to develop. For that you have to do individual practices. Okay. Now I will just introduce you into the place value. Okay. So you have to understand the place value of different numbers. Here, I will take a random number. So for example, it is 829. So 829 is actually 800 plus 20 plus 9. This is what 800 is, which means that 829 is 8 into 100, then like 2 into 10, then 9 into 1. So this is what 829 is. Okay, so 829 is 8 into 100, then 2 into 10, then 9 into 1. If I add each of these numbers, I will get 829. It means that if I consider 829, 1 is the unit number or the unit digit, and 2 is at the 10th place, and 8 is at the 100th place. Okay, so 8 is the 100th place because 8 is like 8 into 100, 800. Then 2 is like 2 into 10, 20. Okay, 29. Then 9 is at the unit place, that is 1. Okay, so this is how we find the digits or the position of individual digits in a particular number. So for example, if it is like 52314, so here 4 is the unit number, 1 is in the 10th place, then 3 is in the 100th place, 2 is in the 1000, and 5 in the 10,000. So why I am emphasizing the definitely I know this particular thing is, yeah, what is? Okay, so I know this is something very easy, like very basics, and like almost all of you know this thing, but they will be asking in the question. Okay, they will be asking in the question like, what is the number in the thousands place or 100th place? Likewise, they will ask. So in that particular case, you should be able to locate that particular number. So for example, I'm taking a random number. Okay, 5, 2, 3, 6, 2, 1. Okay, so this is a random number. So here I am asking like, with which number I have to replace the digit at 100th position so that this particular number is divisible by 9. Okay, so I want to make this number divisible by 9. So that for that, which number I have to replace in the 100th place. So here you should be able to locate the number at the 100th place. That is 6. So I want to replace the number 6 with some other number so that this particular number will be divisible by 9. So which are those numbers? So with which number I can replace 6? So again, to check the divisibility by 9, I have to add these numbers. It is like 5 plus 2 plus 3 plus 6 plus 2 plus 1. So if I add, I will get like 7. 7 plus 3 is equal to 10. 10 plus 6, 16. 16 plus 2, 18. 18 plus 1 is equal to 19. Okay, so in order to make 19 divisible by 9, I can go for 2 options. Okay, so it's like either I can reduce. That is, if I minus one number, I will get 18. So which means that if I replace 6 with 5, then definitely it will be divisible by 9. Or else it will be like 19 has to be converted into 27. So for that, I have to add 8. But if I add 8 here, then obviously this 3 also will change. Okay, this 3 also will change, and that 3 will become 4. So here I can change only one digit, that is 6. So the final answer is that if I replace 6 by 5, then this particular number will be divisible by 9. So what will be the answer? 5, 2, 3, 5, 2, 1. This number is divisible by 9. Okay, so likewise, they will combine the concept, like the different concept that we have studied till now, and they will ask the question. So you should be able to locate the number and their position, like unit place, 10th place, 100, likewise. Okay, so this is the different format that they can ask the question. Now, for like just to give you the information what we have studied, let's consider the number 5482. So the 5000, as you know, it is 5 into 1000. Then next is like 400, that is 4 into 100. Then comes like 80, that is 8 into 10. Then finally 2 into 1, that is 2. When you add each of this number, okay, when you add each of this number, then what you will get? This 5482. Okay, that's how you get this 5482. 482. Okay, so that's what is given over here. Now, I will introduce you into decimals. Okay, so sometimes we have to deal with numbers other than integer. Most of the time, we will be interacting with digital or like the integer numbers like -3, -2, -1, 0, 1, 2, 3, likewise. We will be interacting or like we will be normally using the integers only. But there are instances where we have to use decimal numbers also. Say for example, half. Half is equal to 0.5. Likewise, we may have to use this kind of a decimal numbers. Okay, or like 25, 0.25. That is 1/4 is equal to 0.25. Okay, so likewise, you will be instructed to deal with decimal numbers. So here also you should be able to know the operation, the place value, etc. So here actually the 0.5 means 5 divided by 10. Or I can express this in the exponent form also, that is 5 into 10 raised to -1. Okay, I can express this particular thing as 5 into 10 raised to -1, or as 5 divided by 10, or as 0.5, or as 1/2. Okay, all this have the same value or like the same result, but I can represent it in different form. The first is called the rational number or the rational representation, that is in the P/Q form. The second is like the decimal form. Then the next is also considered as P/Q format, that is rational. And the last is like representing in the decimal form or as a power in the exponential with a exponent in an exponential way, that is 10 raised to -1. So different ways I can represent for the easiness of the calculation. Okay, for the easiness of the calculation, you can represent different numbers by different ways. Okay, so for example, if you have confusion like what is the answer of 0.25 into 0.25? Okay, you are confused like where you have to put the decimal number. So definitely you will do like 25 into 5 This is equal to 125. The answer is 125. Now the question is that where should you put the decimal place? Okay, whether it is over here or over the between 1 and 2, or is it after 1? Okay, where you have to place the decimal number, you will have the confusion. But if you do this particular operation with the exponent form, say for example, 0.5, I can express it as 5 into 10 raised to minus 1. And 25, 0.25, I can represent as 25 into 10 raised to minus 2. So here, you can just multiply 5 by 25. Okay. You can multiply 5 by 25, you will get 125 into, then comes like 10 raised to minus 1 into 10 raised to minus 2. Okay, 10 raised to minus 1 into 10 raised to minus 2. So there is a rule for the exponents. If it is like 2 raised to m or like any number, you can take any number. So here I'm taking x. Okay, so here I'm taking x, some random number, x raised to m into x raised to n is equal to x raised to m plus n. So this is a very fundamental basic mathematical rule with respect to exponents. Definitely we will learn it. Okay, there is no hurry. We will learn it. I'm just showing it, the different use of representing number in different format. So here also, when I add this 2 digits, so here the base is same. It is the 10 itself. And when I add it, I will get like 125 into 10 raised to minus 1 plus minus 2. That is equal to 125 into 10 raised to minus 3. Okay, so here as it is minus 3, you can put the decimal place after 3 digits. That is equal to, if it is 125, then like 5, 2, 1. After that, I have to put the decimal numbers. Okay, so after that, I have to put the decimal number. So it will be 0.125. So you can deal with without confusion, with the decimal number without confusion, if you convert this into exponential form. Okay, so that's the advantage of representing the number in different formats. It will make your calculation easy and without confusion. Okay, that is less confusion, less. So here, just go through this. That is here I have expressed this particular number 3.746 in different format. So here 3 is an integer, so it's like 3 into 1. Okay, that is in the unit place. So here the unit place number is not 6, it is 3. Okay, so when we consider 3.746, the unit place number is not 6, but it is 3. Okay, then the 7 is 1 by 10. That is 1 by 10 into 7. That is equal to 0.7. Then 1 by 100 into 4. That is equal to 0.04. Then 6 by 1000. Sorry, 1 by 1000 into 6 is equal to 0.06. Okay, 0.006. Okay, so when I add each of this number, I will get what? 3.746. So it will be like, I'm just expressing it in the right form. That is 3, then 0.7, then 0.04, then 0.006. Okay, so this is how I can represent the numbers. Okay, now just add this number. Then I will get what? 3.746. Okay, so you should be familiar with the decimal numbers, its conversion, its addition, subtraction, multiplication, all those things. We will deal with them in detail later. So here I am introducing you to the decimal numbers. Okay. So let's solve some problem. Okay, so here you have to solve this particular problem. I will just give you 2 minutes. Try to solve it by yourself. Okay. I will just give you 2 minutes. Try to solve it. As it is a math session, you should practice. Okay. Then only you will be able to understand the concept properly. So here I have given this problem to you. This is one of the previous year question also. That's why I did just take the screenshot. Okay. This is a previous year question. Just try to solve it. Okay, what is the answer? You can say A, B, C, D. Okay.
C.
Okay. So some says it is C. Then others.
It's B, sir.
Yeah. You says it is B. So anyway, let's check. Okay. So I want to change the expression 2 1 by 2 into a proper P by Q form. I want to change this. So what I will do? First of all, I will multiply these two numbers. Okay. Then I will add this number. So it is like 2 into 2 plus the remainder 1 divided by 2. The same way, 3 1 by 3 is equal to 3 into 3 plus 1. I have multiplied these two numbers and added this. Okay. Then the same way, 4 1 by 4 is equal to 4 into 4 plus 1 divided by 4. So this is how I can convert each of these numbers into P by Q form. So the first will be like 2 into 2 is equal to 4. 4 plus 1 is equal to 5. So that is 5 by 2. Plus the second one, 3 into 3 is equal to 9 plus 1 is equal to 10 divided by 3. Plus 4 into 4 is equal to 16 plus 1 is equal to 17 divided by 4. Okay. So if I want to add these numbers, I want to make sure that the denominators are the same. Okay. So the denominators should be the same or the common. So here the denominators are different, like 2, 3, 4. They are entirely different. So what I will do, I will make the denominators same. So here, I want to find a number where each of this number 2, 3, and 4 is a factor to that particular number. Okay. So that particular number is 12. Okay. So 2 is a factor to 12, 3 is a factor to 12, 4 is a factor to 12. So in order to convert this 2 into 12, I will multiply the numerator and denominator with 6. So it will be like 5 into 6 divided by 2 into 6 plus. Then the numerator for this 10 by 3. In order to convert this 3 into 12, I will multiply the numerator and denominator with 4. Then it is 10 into 4 divided by 3 into 4 plus. Then the 17 divided by 4. So here I will multiply the numerator and denominator with 3. So I will get 17 into 3 divided by 4 into 3. So as you can see, here the denominator is 12. Okay. So whatever the numerator, I can just add this number and the denominator anyway is going to be 12. So obviously the answer is B. You don't have to solve the entire problem. Like if you want, you can solve because 5 into 6 is equal to 30, then like 40. Okay, then plus 51. If you want, you can add this and solve the problem, but there is no need. You just want to find this denominator. This is the method of solving this particular problem. Okay, but those who are well acquainted with the maths, those who know the tricks of the maths, what they will do? Sorry. So what they will do? They will just look into the denominators of the numbers given. So the denominators are like 2, 3, and 4. So the denominators are 2, 3, and 4. Then they will go immediately for the common number, that is the LCM. We can call it as lowest common multiple, LCM, or like one number, say for example X, where each of this number is a factor, and they will find it is as 12, and they will immediately mark B. Okay, so that's how the practice makes you perfect when it comes to maths. So it will increase your accuracy as well as the fastness. Okay, you will become so fast, and with just looking into the question, you will be able to pick the right answer. Okay, so that actually makes a huge difference in any examination, any competitive examination. Now, I just want to introduce you into a concept called BODMAS. Because when we operate with the numbers, when we deal with the numbers, there will be like different operations. Like there will be addition, subtraction, then there will be like division. Okay, then there will be like brackets and all coming, and we have to deal with each of those numbers. So we should know what operation we have to do first, because if we don't do each of this operation in this sequential manner, then we won't get the intended or the right answer. Okay, I will just show you this thing. So this is one question, that is 20 divided by 4 into 10 divided by 5 into 2. So you just have to do this. You have to solve this problem. Okay, so what you should do, you first try to solve it from here, from the left to right. Okay, try to solve this particular question from left to right. Okay, and then try to solve it from right to left also. Then check whether you are getting the right answer in both the time, or the answers are same. Okay, just check whether the answers are same or not. Okay, just do it from left to right and then from right to left. I hope like you may have done. So let me try it. Okay, so here first 20 divided by 4, that is equal to 5. 5 into 10 divided by 5 into 2. So 5 into 10 means 50 divided by 5 into 2. Now 50 divided by 5 is equal to 10 into 2. The answer is 20. Okay, so if I try to solve it from here, from left to right, the answer is 20. Now, again, let me solve it from right to left. Okay, so if I try to solve it from left to right, then it is like 20 divided by 4 into 10 divided by 5. 5 into 2, that is 10, isn't it? 5 into 2. If I try to solve it from right to left, 5 into 2 is equal to 10. Just a second. This is 10 itself. Okay, so 10 divided by 10 is equal to 1. That is 20 divided by 4 into 1. Okay, now 4 into 1 is 4 itself. So 20 divided by 4. Now 20 divided by 4 is equal to 5. So here you got the answer as 5. Here you got the answer as 20. See the difference? Okay, so if you are not doing the particular like solving process in the right direction, you won't get the right answer. You will be getting different answers. Okay, so there is a sequential order. There is like a very well ordered way that you are supposed to solve the problem. Here, like whatever the operations that you have done, like whether it is the multiplication, division, okay. So whatever the mathematical operation that you have done, it is same. Okay, whether you did it from the left to right or from right to left, you did it in the same way. In both cases, you have divided 20 by 7. You have done 20 by divided by 4. You have done the operation. But the answer you got is different. Okay. So in both cases, you have done it. Here also, like in the first case also, you have divided 20 by 4 and you got this 5. So in the other case also, you have done this 20 divided by 4. But the final answer is like entirely different. What makes this different? It is just because the direction. So you should know which operation you have to do first. So if you don't do the operations in the right sequential way, then it will be difficult for you to get into the right answer. So when it comes to the mathematical operations, you should do the first you should do the brackets. Okay. Then if there is some exponents, powers, root, etc., you have to solve that. Then you have to go for the division. Then you should do the multiplication. Then you should do the addition. Then you should do for the subtraction. Okay. So this is the order you're supposed to solve the problems. So in order to remember this order, you can go for BODMAS. Okay. Just remember BODMAS. So B stand for bracket, O for order, D for division, M for multiplication, A for addition, and S for subtraction. Okay, so you can remember this as BODMAS. Now regarding this particular problem, in any case, whether you are trying to solve any problem, you have to start it from left and you have to do it to the right. Okay. So if you consider this particular problem, this is the right way. You have to start it from left and you have to solve it from left to right. Okay, so that's the way you can get the right answer. So otherwise, even if you do the right operations, you won't be able to get the right answer. So you have to do it from left to right. Okay, so I hope that idea is clear to you. Now, this is also a basic question. Okay, so that's a different question. It was asked in one of the state examination. So let's do with this particular question. Okay, so just try to solve this question. Okay, so it's already 4:14. Okay, like you can take the screenshot and try to solve this problem by yourself. Okay. So as it is already 4:14, I want to introduce you to some other concept. So I'm just moving a little bit fast. Okay, now we are going into exponents. Okay, so what is mean by exponents? So the exponents is simply like the powers that we will be expressing the different numbers. As I said, we will be expressing different numbers in different ways. So the exponents means, say for example, if there is like 5 and I multiply 5 by 5, I will get 25. Okay. So I have multiplied 5 by 5. Okay, so here it is actually 2 5. So I will express this as like 5 square. Okay, I will write the 2 in a small digit, like as a small number that is raised as a power to 5. This is equal to 25. So what if I multiply 5 again by 5? Then I will get like 125, which means that 5 cube is equal to 125, or like 5 to the power 3 is equal to 125. Okay, so this particular way of representing or writing the numbers is called exponent form. Okay, so here the exponent of the 5 is 3. Okay, so this is the exponents, and it helps us in solving the problems in most of the cases. So here you should know some of the basic principles regarding the exponents, some of the basic operations. So the first thing you should know that if we write a number like this, like 5 square, as I have written earlier, 5 square, or like 4 square, you will get like 25 and 40, like 16. It is like 4 into 4. And this is 5 into 5. So in all the cases, with the square, you will get a positive number. You will never get a negative number. Okay, with square, you will always get positive number. This is one rule that you should know. Okay, and what about the cube? What about cube? So for example, 5 cube. Okay, so in 5 cube, you get 125. It is a positive number or a positive integer. If it was like minus 5 cube, then what it will be? So here it will be like minus 5 into minus 5 into minus 5. As you can see, minus 5 into minus 5, this is plus 25. Okay, that is minus into minus. Minus into minus is positive. So if I multiply minus 5 by minus 5, I will get 25. That multiplied by minus 5 is equal to minus 125. It means that positive into negative is equal to negative itself. So it simply means that if it is cube, then the sign will depend upon the base number. Okay, the sign will depends upon the base number. Whichever the base number, here it is minus 5. So the sign of the minus 5 is negative. So the final answer is also negative, that is 125. So if it is cube that you are going to find, so in that case, it will hold or it will maintain the sign of the base number itself. So for the square, you will always get a positive number, but for a cube, you will get positive and negative number depending upon what is the sign of the basic number. Okay, or the base number. Now, some of the rules you should know with respect to the exponents. Okay, so these rules you should remember and you have to memorize. So the first rule is a raised to m into a raised to n is equal to a raised to m plus n. So let's take an example. So for example, if it is 2 raised to 3 into 2 raised to 4. So here m is equal to n, sorry, m is equal to 3 and n is equal to 4. And a is equal to 2. So what will be the answer? It will be 2 raised to m plus n, that is 3 plus 4. That is equal to 2 raised to 7. Okay. So the same way, if I can do the subtraction also, or like the division also, in such cases, a raised to m divided by a raised to n is equal to a raised to m minus n. So I'm taking the same example for the better understanding. That is 2 raised to 4 divided by 2 raised to 3. What will be the answer? The answer will be like 2 raised to 4 minus 3. That is equal to 2 raised to 1. That is equal to 2 itself. Okay. So here the answer will be 128. If you multiply 2 7 times, you will get 128. Okay. So that is equal to 2 raised to 7. And 2 raised to 1 is equal to 2 itself. And there is one more concept that you should know. Okay, so I'm just erasing this. One more like theorem that you should know, that is power of the power. Okay, that is a raised to m all raised to n is equal to a raised to m into n. Okay, this is also one rule you should know. That is a raised to m all raised to n is equal to a raised to m into n. Okay, so I will take the same example again. 2 raised to 3 all raised to 4 is equal to 2 raised to 3 into 4, that is equal to 2 raised to 12. Okay, so why I took the same number itself, it is to show you the difference in the result. So in the first case, it was 2 raised to 7, that is equal to 128. So in the second case, it was 2 itself. Then in the next place, it was 2 raised to 12. Okay, so just with the different operation, you will be getting different numbers. So you should be well acquainted with each of these operations that you are conducting with the numbers, with the exponents. So here also you should remember one thing. Here the base is the same. For every number, the base is a itself. Okay, so only if the base is like common, if the base is common, then only you can do this particular operations. Okay, so here the operation for like the base for all the number, that is a is equal to 2. Okay, so here the base for all the numbers is 2. That's why I was able to multiply, or I was able to solve this particular problem. Okay, then there are few more rules also with respect to the exponents that you should know. So the first rule, the next rule that we are going to discuss is like the power of the product rule. So when it comes to the power of the product rule, if it is like a into b all raised to m or like n, then it will be like a raised to n into b raised to n. So it's like 2 into 3 all raised to 2. This is equal to 2 raised to 2 into 3 raised to 2. Okay, so here like you can do in both ways. So here it will be 2 raised to 2 means 2 into 2, that is equal to 4. Then 3 raised to 2 means 3 into 3, that is equal to 9. So here on the left hand side, it is 2 into 3, that is 6. 6 square. So 6 square means 6 into 6, that is equal to 36. So on the other side is also 36. Okay. So if it is like a b raised to n, then a raised to n into b raised to n. Then the other rule is like quotient rule. Okay. So earlier we have studied for the multiplication. Now for the quotient, if you divide, if it is like a by b raised to n or like m, then it is a raised to m divided by b raised to m. Okay, it is a raised to m divided by b raised to m. So this is called quotient rule. So to take an example, if it is like 6 divided by 3 raised to 2. Okay, or I will go for like 3. Okay, we have been taking 2 for so long, so I will just take 3 this time. So 3. So what is the answer? So I can solve it both ways. So the first is like 6 raised to 3 divided by 3 raised to 3. So the first is like 6 raised to 3 is 36 into 6. That is 216 divided by 3 raised to 3 is equal to 27. Okay, so the final answer will be like 216 divided by 27. This is what I get. Okay, so here also on the left hand side, 6 by 3 is equal to 2. Then 2 cube, that is equal to 8. So here also it is 8. Okay, so in both cases, it is the same answer. So you can either divide the number within the bracket and give the power, or like you can assign the power and divide the numbers. In both cases, you will get the same answers. Okay, so this is called quotient rule. I hope this idea is clear to you. Okay, so you should be like very well with the powers, with this exponents. Then only you will get the answer correctly. Okay, then only you will get the answers correctly and in a perfect way. So just remember each of the rules. Then finally, you have to remember one rule that is called unity rule or like zero exponent rule. That is any number raised to 0 is equal to 1. So for example, if a is like 1000 or if it is like 10,000 raised to 0, the value is 1. So irrespective of the value of the base number, if you give the exponent as 0, then the answer will be 1. Okay, so you have to remember each of these things. Now, other two ideas that you should understand with respect to the exponent is negative exponent rule and the fractional exponent rule. Okay, so what is negative exponent rule? It means that, as you know, 2 raised to 3 is equal to 2 into 2 into 2, that is equal to 8. But what is 2 raised to minus 3? This is equal to 1 divided by 2 raised to 3. Okay, that is equal to 1 divided by 8. Simply, the negative exponent means it is the reciprocal. Okay, each of this concept you should be very much familiar with, because in the upcoming classes, we will be going into the higher concepts. So there you will need each of this concept. So I won't be repeating this concept there. I will just take the problem and I will say that we have studied or like I have taught you each of this concept in our previous class and we will just move on. So it's your responsibility to study each of this thing today itself, or by just listening to this class, you have to make the notes and you have to be thorough with this. Okay, so then negative exponent rule, it simply means inverse. Okay, it simply means inverse. You have to take the reciprocal of the number. Okay, and what is meant by the fractional rule? The fractional rule means if, say for example, eight raised to 3. Okay, this is equal to 64 into 8. Okay, so this is equal to 64 into 8. Then the same way I can represent this particular number. Okay, 64 into, this is equal to 512, if I'm correct. Okay, so I can represent the same number as a power of the 2 also. That is 2 raised to 3. Okay, into 3, isn't it? 2 raised to 3, that is 8. And this is a power to 8. Okay, so this is a power to 8. This is equal to 2 raised to 9, that is equal to 512. Or simply, if I take the cube root, okay, that is 8 raised to 3. And if I take a cube root, it is expressed as this way. The answer is 2. Okay, so what I did here is that 8 raised to 3, and here I like multiplied the power with 1 by 3. That is what's mean by the fractional rule. Okay, so 8 raised to 3 into 1 by 3, this is equal to 8 raised to 1. Okay. So here it is not 2. Okay, just let me correct it. Here it is 2, 8 itself. Now I'm just going for the 8. What is the cube root of 8? So in this case, you have to express 8 as a form of power of some number with 3 as exponent. So as I said, 8 is actually 2 cube. So it's like 2 cube root 3. That is equal to 2 to the power 3 into 1 by 3. So it goes into cancel, then the answer is 2. So simply fractional exponent rule means you have to multiply the power with that particular number. If it is like 1 by 2, you have to multiply it with 1 by 2. If it is 1 by 3, you have to multiply it with 1 by 3. Okay, so this is a previous year question that is already asked. So here, even though the question may seem bit difficult because they have asked like 6 raised to 15, which is a very large number, very huge number. So what they have asked is, what is the unit digit of 6 raised to 15? Okay, so what is the unit digit of 6 raised to 15? So here, as you can see, okay, so here, as you can see, you don't have to go and solve the 6 raised to 15. Okay, you don't have to. So what you should do, you have to use your logic. Okay, just use your logic and think, is there a pattern? Just to find out whether there is a pattern. So as you know, if I multiply 6 by 6, I will get 36. Again, if I multiply 6 by 36, I will get like 216. So how many number of times you multiply 6 with 6 itself, you will get a number and the unit place of that particular number will be 6 itself. There is no change. Okay, so there is no need to solve this particular problem. And if you know this concept, you can immediately mark the right answer. The right answer is C. Okay, so how many number of times you multiply 6 with 6 itself, you will get a number with 6 at the unit place. You don't need to solve this problem. It is very easy for you. Okay. Now, we will stop this class by solving this particular problem also, because after that, we will be going into different other new concept. Okay. So just try to solve this particular problem. So after this, we will wind up. Okay. Then the next new concept, we will start from the next class itself. So I will just show you how to solve this particular problem. Okay. So this is slightly different. So the question is like 4017 and the power is like 754. If you try to solve this particular problem in calculator, you won't be able to find the answer. It will just show like infinity. Okay, even the calculator won't be able to solve the problem. So how we will solve it? Anyway, we want to find the answer because they have asked for the last or the unit digit. So here, again, you have to go and you have to find the powers of the 7. So first there is 7. Now 7 into 7 is equal to 49. Okay, so 7 into 7 is equal to 49. Now what is 49 into 7? So what is 49 into 7? So 49 into 7 is equal to 7 into 7 into 7. That is 49 into 7. That is equal to 343. Now, what is 343 into 7? Okay, so that is 7 into 7 into 7 into 7. That is equal to 343 into 7. That will be around 2401. Okay, now what will be 7 raised to 5? That is 7 into 7 into 7 into 7 into 7. That is equal to 2401 into 7. Okay, so 2471 into 7, that will be 16,807. Now you got the pattern. First, it was 7 into 1, that is equal to 7. Now check the number at the unit place. First, it was 7. Then it was 9. Then it was 3. Then it was 1. Then it was again 7. So this pattern will continue. So the pattern is like 7, 9, 3, 1. Then again it will be 7, 9, 3, 1. So for every 4 number, there will be one set pattern. Okay. So what will be the power of like 7 raised to 10? Like the number at the unit place. 7 raised to 10, what will be the number at the unit place? It is easy. Because for 7 raised to 8, this pattern will continue and the last number will be 1. So after that, 7, 9. So 9 will be the number at the unit place for 7 raised to 10. Okay, so here they have asked not 7 raised to 10. Okay, they have asked for 7, this particular number raised to 754. So why I took 7 here? Because 7 is the number at the unit place of the 4017. Okay, so here it is 7 itself. So whenever I multiply this particular number with 7, it's always this 7 is multiplied with the multiples of the 7 itself. So that's why I took it. Okay, so here it is 754. Now I just want to know how many number of times this pattern is repeated. So for that, I will divide 754 divided by 4. Okay, so in 4, it will go one time, then it is 35. Okay, so it is 35. So 32, it will go. Then the remainder will be 2. Okay, so I'm just taking the remainder. 752 by 4. Like the 4 can divide 752 easily. Okay, but for 754, it will create 2 as a remainder. So what will be the answer? Again, this pattern will repeat for the like 752 times, and the remainder is 2. So the answer or the remaining number will be 9. So the answer will be 9. Okay, so the answer here is 9. So this is how you will find the answer. Okay, in the maths, you just have to find some relation, some patterns. Based on the patterns, you can create your own, like the numbers. You can find the answers very easily. So it's all based on the pattern. You have to find the answer. Okay, so there are 2 more problems. So once I share this PDF, this PPT, you can go through this particular questions and try to solve this question. So this is a homework for you, the last one question, and there is one more question. We will try to solve this problem in the next class. So these 2 questions that will be there in the PDF. So try to solve this problem. If you are not able to do it, we will do it in the next class. Okay, so there are like many more concepts that we have to like study. Okay, so each of this concept. So from here onwards, we will be starting the application of whatever we have studied. Okay, so before that, you have to be thorough with it. So I'm giving you the 2 homeworks. You have to complete this. You have to try to solve this so that you will be sure that you are able to solve, you are able to understand each and every concept. Okay, so with this, we are winding up today's class. I hope each and every concept was so clear to you. Okay, so just study well. Okay, so that's from my side. And if you have any like queries or any doubts, then you can ask. Okay, I think like you don't have any other doubts and all those things.
Thank you. Thank you, Shahid sir, for your class.
Okay.
A request to share the PPT of today's class.
Okay,
So
sir, I
that,
will share it.
People will go ahead and do their homeworks.
Yes, sir. I'm supposed to take the class by like till 5, but there is a death in my family, so I want to go immediately. So that's why I'm winding up the class today. So thank you, everyone. Yeah, thank you, Shana.
And dear participants, I need to know. See, I'm a group admin there, so you can message me personally and ask the questions, whatever related. Because I see most of them, are on and off to the classes. Is there any difficulties for you to join the application, write the test? Please ping me in WhatsApp, or you can call me at any time during the office hours. I will be attending your call. Thank you very much for today's class. We are ending the class now. Thank you.